In this video, I am going to talk about interconnections of networks. First being series connection. When two networks are connected in series, how to determine the Z parameters of such a network? So that is the objective of this particular video. Let us try to consider two networks, NA and NB, and let us try to connect them in series. Okay, so we will do that. This would be the structure. Alright, how have we connected? So we have a network N suffix A. This is network A and this is network B. Network A has got two terminals which would make it an input port which has parameters of V1A and I1A. Network A has got its output port. You may name it as 2 and 2 dash, though I haven't named it here. It has parameters I2A and V2A. So these are the positive directions of measurement of the voltages and currents. Alright. And network B is indicated by NB. This is the network B, which again has got its two ports. This is input port having parameters V1B and I1B as the voltage and current respectively. And V2B and I2B are the parameters of the output port of the network B. Alright, so network A and network B are connected in series. So the current that comes out, I1A, that comes out of the terminal is connected to the input terminal of network B, and the current I1B goes out. So I1A gets in, I1A comes out, and that goes into I1B, and I1B comes out. Alright, similarly, we have done the same arrangement in the output port. Now, these two networks are now said to be in series. They are something like, one getting connected to the other. They are in chain like. Okay, it's a series connection. So, if you can see this network, this whole orange, this orange box, and which encloses NA and NB series combination, again can be seen as one two-port network having terminals. I will name these terminals, maybe that would be better. I would name these terminals. I would take the same violet color. Where is that? This color I'll take. This is my 1 and 1 dash. This is my 2 and 2 dash. This is for the entire combination. Now this combination of two-port networks, it has got I1 V1 and I2 V2. And these are the positive directions of measurement of voltages and currents for two-port network. Now, what is our objective? Our objective is to determine the overall Z parameters of this overall network that we have obtained after combining NA and NB in series. Alright. So, now we will try to write the fundamental equations that can be seen by inspection. We will first try to write the relationships. If you can see this network, it's very clear that is by inspection, by looking at the network or by looking at the kind of connection that we established, we can easily write the current I1 is also equal to the current I1A is also equal to the current I1B, right? So one tends to say that when the current is the same, then the networks are in series. Or in other words, when the networks are in series, the currents would be same. The current flowing to the two networks would be same. Different ways of looking at the same thing, right? So similarly, if we can write what is I2, I2 is same as I2A, is same as I2B. Alright, so this is a very, very fundamental relationship that we can obtain. We will call them 1 and 2. Let this be equation 1. Let this be my equation 2. Okay, in series combination, the current is same, right? The current through the A network is same as the current through the B network is same as the current of the combination. Alright, or the equivalent network. This is the current to the equivalent network. So output current of the equivalent network is same as the output current of the A network is also same as the current through the B network. This is a very, very fundamental relationship. There is another relationship with regard to the voltage. We can easily see what is V1 equal to. If we can look at the network, V1 equal to V1A plus V1B. Voltages are additive. Okay, the input voltage V1 of the combined network is the sum of the voltages of the A network and B network. Right? So that is simple. V1A, this voltage V1A and V1B is equal to V1. Alright, similarly we can write what is V2 equal to. V2 equal to V2 of A plus V2 of B. Okay, these voltage relationships we will call it as equation 3 and this is equation 4. Okay, so we have 4 relationships, 2 for currents and 2 for voltages. Okay, now what is our objective? We are trying to get the Z parameters of the series connected network. Okay, so we can easily say for A network, we will independently write the equations. For network A, that is our NA, the network NA, how do we write the equations? We can simply write V1A equal to, what is the equation for V1A? So V1A can be written as Z11 A I1A plus Z12A I2A. Okay, this is for V1. And another equation we have for V2. V2 of A is equal to Z21 of A I1A plus Z22 of A I2 of A. Okay, this is for the voltages of A network. Similarly, we will write for B network. Okay, for network B, what can we say about the network B? What I'll do is I'll try to copy this entire thing. Copy, paste it over here. I'll do some changes. I'll remove all these A's. This is convenient for me. I will replace them by B. Okay? Wherever I had A, now I have B. Okay? This is for network B. Okay? So for network A, for network B, we have the voltage equations. This is how Z parameters are connected, right? So voltages and currents of A network are connected to each other with the help of Z parameters. Similarly for network B. Now we will make use of equation 3 and 4. Okay? In equation 3, if we see what is V1, V1A plus V1B. So we will write V1A is this, V1B is this. So we will try to substitute. And then we will try to substitute for V2A and V2B in equation 4. Because ultimately what are we interested in? We are interested in what is the relationship of V1, V2 with I1, I2. Alright, so we will try to substitute, make use of these relationships and simply do the substitution from equation 3. We will try to first take equation 3. Okay, from equation 3. This is in fact a derivation. This is a derivation. So I thought I would take it up because a student of mine requested. So I thought I would take it up. So from equation 3, what is it we get? So we get V1 equal to, okay, so we have to substitute for V1A, right, from this relationship. Okay, so we will try to, if you want, I can call this equation 5, 6, 7, 8, etc. we can, okay, I'll do that. I'll do that because this is 5, this is 6, this is 7, this is 8. Okay, so from equations 3, 5 and 7. So in equation 3, I am trying to substitute 5 and 7. All right, so what is it I get? And also, no, I'll not do it right now. I'll do it later. Okay, so V1 equal to, this is Z11A. I will take this much. I'll take this. This I'll copy. I'll take it here and I'll paste. Okay, and again I'll take this. V1B I will take from this. Why is it I'm not able to copy here? Okay, I'll copy. I'll paste it here. I'll put a plus sign. Okay, my equation 3 becomes like this. After substitution of 5 and 7 in equation 3, I get this. Okay, and now what I'll do is, I'll make use of my equation 1 and 2. Okay, so from 1 and 2, wherever I have I1A and I1B, I will put I1. Wherever I have I2A and I2B, I'll put I2. So what I mean is, I will write that. Okay, I'll substitute from equations 1 and 2. From equations 1 and 2, what will happen to this equation? I will copy this equation now. Every time instead of writing, I'm having a shortcut. Okay, I have substituted that equation. Maybe I need to pull it here. Okay, I've substituted this equation. Now what I mean is, wherever I have I1A, I will simply write it as I1. I2A is I2. I1B is I1. I2B is I2. Alright, now I will group the terms. What I mean is, I will collect the terms. This is Z11A plus Z11B, whole thing multiplied with I1, plus Z12A plus Z12B, whole thing multiplied with I2. This is what is V1. Okay, so I'll call this equation. This is an important equation for me. Okay, so I'm able to get one equation relating V1, I1 and I2. Alright, now I want one more equation for V2. So what do I do? I'll make use of 4, 6 and 8. So instead of 3, 5, 7, I'll make use of 4, 6 and 8. Okay, in equation 4, I will try to substitute 6 and 8. So from 6, I know what is V2A, and from 8, I know what is V2B. I will try to substitute for V2A and V2B in V2. So what will happen to my equation 4, 6 and 8? From equations 4, 6 and 8. Okay, I'll pick this. I'll copy. I'll paste. Okay. So I have equation 4, equation 6 and equation 8. So what is it I get? So I get equation for V2, right? So I'll get equation for V2. So V2 equal to V2A. Okay? So V2 equal to V2A. So I will take that equation of V2A. Only the right hand side I need. Only the right hand side. I'll copy this. I'll paste it here. Okay, and I will have to take V2B. I'll take V2B. The right hand side of V2B I'm taking. I'll copy this. plus, okay, I'll put first paste, then I'll put a plus here. Alright, now what I'll do, again I'll take equation 1 and 2. I'll now make use of equation 1 and 2. Not 1 and 2, rather I'll make use of equation 1 and 2, precisely. Equation 1 and 2. Copy. And paste. Okay, so what I'll do is, wherever I have I1A, I'll put I1. Now I'll take this equation again. I'll take this equation again. I'll paste it here. Now I will try to write, wherever I have I1A, I'll put I1. Wherever I2A, I have I2. This is I1B, which is I1. I2B, which is I2. Again, I'll group. What is my V2 equal to? V2 equal to Z21A plus Z21B whole thing into I1 plus Z22 of A network plus Z22 of B network into I2. This is my equation. Okay, so look at equation 9 and 10. I'll collect them. Okay, let us collect these two equations in one place. What I mean is, I will pick up equation 9, paste it here. Okay, this is my equation 9 and this is my equation 10. Okay, I'm sorry, I didn't take this as 9. This is my 9. This is copy. Okay, 9 and 10 I have built. Now, for the entire network, if I can write, this is my equation 9, equation 10. I'll pick up a color. This is my equation 9. This is my equation 10. Alright, so for this entire network, which has resulted out of the series connection of two independent networks, NA and NB, we can write for the entire network, or for the resultant network, by resultant network, what I mean is the network that is obtained after connecting two networks A and B in series. For the resultant network, we can simply say V1 equal to Z11I1 plus Z12I2 and V2 equal to Z21I1 plus Z22I2. This is how Z parameters are connected. So we will try to compare these two equations with equations 9 and 10. Okay, so on comparing equations, with equations 9 and 10, what can we say? 9 and 10, we can say that Z11 equal to Z11A plus Z11B, Z21A plus Z21B. Similarly, Z12 equal to Z12 of A network plus Z12 of B network. Z22 of the combined network is the sum of the Z parameters of the network and network A and network B. That completes our proof. So what are we to conclude? From this derivation, what is it we conclude? If we want the Z parameters of a series connected network, then the z parameters of the resultant network is the sum of the z parameters of the independent networks. That is what is the conclusion. Okay, so the z parameters of the overall network, that is z11a, z21, z12 and z22, is nothing but the sum of the z parameters, corresponding z parameters of the individual networks. So that is what is the proof. Or if we want to put it in some sentence, we can simply say that when two networks are connected in series, I will write it down for you. Or should I use a text box and let me see if I can type it properly? One second. I will not draw. What's happening? At times it gives me little trouble. I don't want to draw. What is this off thing? Okay, I will try to write it here. When two networks, sometimes these things give me some trouble. Okay, let me see again. Sometimes, I'll tell you, easier. Why is it by default taking up black is something I fail to understand. Damn. I've done it several times. Okay. Okay. Wait a minute. Let me see what is happening exactly. Okay. When two networks, okay, are connected in series, and two connected networks are connected in series, the equivalent network or the network that results, what I mean is, will have the z parameters to be equal to the sum of the Z parameters of individual networks. Okay, that is what I mean. At last, I could type. Okay, so what I mean is, when two networks are connected in series, the equivalent network will have Z parameters to be equal to the sum of the Z parameters of the individual networks. So if at all I want to write the equations in equation form, what I mean is V1, V2 in the vector matrix form is equal to, we can write it as Z11A plus Z11B, Z21A plus Z21B, and here I have Z12A plus Z12B, Z22A plus Z22B, and I1, I2. Okay, this is what I mean. Okay, this entire thing can be treated as Z11, this is Z12, this is Z21, and this is Z22 of the resultant network. So it is easy for us to determine the Z parameters of the resultant network whenever we have two networks in series, and then if at all we want to have any other parameters, we know the interrelationships. Okay, how one parameter can be expressed in terms of other parameters and vice versa. We can always do that. So it's easy to determine the Z parameters whenever you have the networks connected in series. That is the overall understanding of this particular derivation. I suppose this derivation is clear. So whenever you have two networks in series, try to get the Z parameters of the resultant network, and then if you are interested in, let us say, ABCD parameters, you can always obtain ABCD parameters from Z parameters. That derivation we know. Right? We can always do that derivation also from one parameter to another. It is a very, very simple fundamentals. If you do it for one, you can extend the concept for any other, relationship between parameters. So, Y parameter can be expressed in Z parameter and vice versa, and so on and so forth. We have 6 set of parameters, right? So, all the 6 set of parameters can be interchangeably expressed one in terms of the other. That is possible. Alright, so I will stop this video here. I'll try to take up the 2 more connections, parallel connection and the cascade connection. Okay, so how do we get the relationship? Okay, so I will stop this video here, and please do let me know your feedback, your opinions. Okay, if you can subscribe for the channel, you will be notified. Okay, thank you so much. Thanks for watching.